Hello, are you able to see the slides? Hello,
Yes, sir.
I'm changing. Please confirm you are seeing the change. Are you seeing the change slide?
Yes, sir.
Okay, thank you. Okay, we are on to, hello, welcome you all to Department of Chemical Engineering, Banastali Vidyapeeth. We are on CHE 305 Chemical Technology Lecture 34. In the last lecture, we had seen the interesting technology for making soaps and detergents. After taking bath, you would like to apply a perfume, that is essential oil. You would like to catch up a nice hot snack, you need edible oil. So we are picking up the topic edible and essential oils. Okay, edible oils by common sense mean that they are fit for cooking and for human consumption. Essential oils are not meant for human consumption. You don't pour a perfume and drink it. You just apply. Okay, so be careful about what is edible oil and essential oil. Oils are organic molecules of carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen, high, right? Because remember, there will be COOH, right? And sometimes nitrogen and sulfur, but carbon, hydrogen, oxygen, pakka, right? It is composed of long chain fatty acids and esters, glyceride ester, as well as derivatives of glycerine, long chain fatty alcohol, sulfate, and sulfonates. These are general definition of oils. Oils like castor oil, linseed oil are non-edible. Castor oil, linseed oil are non-edible, and oils like groundnut oil, coconut oil, till oil, mustard oil, they are all edible, right? Sunflower oil, all are edible. But castor oil, linseed oil are for industrial application, lubrication, etc., but not for edible cooking purposes. Oil is used in producing vanaspati ghee. First, get some quick difference. Remember, oil is a liquid, whereas ghee is a solid. Okay, oil is a liquid and ghee is a solid. So I can convert oil into a solid called vanaspati ghee, right? And soaps and detergent. Oil is the raw material. Remember, for soaps and detergent, oil is also used for making cosmetics. Oil is used for making medicine, polymers, paints, and varnishes, and in many other applications. So oil, these oil, castor oil, linseed oil, groundnut oil, coconut oil, mustard oil, they are all used in producing a variety of things. What are the components of edible oil? Components of edible oil. Many components are found in typical vegetable oils such as canola oil. Canola oil is something similar to our mustard oil. Uh, it has got a name canola because it was made in large quantities in Canada. So this oil is called canola oil. The flowers of canola, they look like the mustard, but composition will be a little different between mustard oil, canola oil, but also it is called rapeseed oil. Okay. Other edible oils have varying percentage of same constituent. More or less, the composition of the oils are same except in terms of percentages, right? Component listed as minor comprise less than 1% of canola oil, yet these parts play a very large part in determining the stability, therefore shelf life of the oil. So there are some which are very minor, just about 1% of the total oil, but they play a significant role in determining the behavior and properties of the oil. Many of these minor constituents interact readily with oxygen in the air or other components in the oil to oxidize and form the products associated with rancidity. You remember some oil, when you pour into the frying pan, they start foaming, etc. It is all because of a small component present which starts interacting, and this rancidity is like, let's say, foaming type and foul smell even, right? And other of these minor components are antioxidants. They work to keep components free from reacting with air to form compounds associated with rancidity. Right, and rancidity happens because there are some chemicals in the oil which will interact with oxygen and form. Antioxidant means antioxidant will not allow you to react with oxygen. But there are also some components which are pro-oxidant. They get oxidized and form rancid. Right? Antioxidants resist oxidation, so help to preserve the quality of the oil, whereas pro-oxidants promote oxidation, so do not help to preserve the oil. So it's clear that the pro-oxidant must be got rid and the antioxidant must be retained. Let's look at the composition of the oil. This is for canola oil. So canola oil has got oleic acid 60%, very big size. And out of the remaining, linoleic acid is 22%. Linolenic acid is 10%. Palmitic acid is 5%. Stearic acid is 2%. And these minor components are about 1%. And it is these minor components which contain, these pro-oxidants and antioxidants. Mustard oil has a special fatty acid composition. It contains 20 to 28% oleic acid, 10 to 12% linoleic, 9 to 9.5 linolenic, 30 to 40% erucic acid, not there in canola, which is erucic is not it is indigestible for human and animal organism. And if you want to know more details about this, we could just have a look here. Yes. Are you able to see this table? Hello?
Yes, sir.
Yes, see. You see here all the names of oils are given. Coconut oil, corn oil, cottonseed oil, dupa fat oil, groundnut oil. All these oils are listed here. Okay. And here you have the table which gives you their percentage of oil or in the seed and their specific gravity, their saponification value, which tells the fat content, their iodine value, which is a very specific parameter. We will see what it is. Then all these things, hexoic, C10 component, C10, right? Like this. How much is lauric acid, capric acid, caprioic acid, palmitic acid, stearic acid? They vary in percentage. In some they are 2%, in some they are 55%, 3%. It varies. So from oil to oil, the composition differs. So this is a table which you can have a look. So any oil we could get their typical composition here. Okay, coming back to our slide. Okay, we are back on the slide. Are you able to see?
Yes, sir.
Okay. So now, I told you that these minor components, they contain antioxidants and pro-oxidants. Antioxidants, they resist rancidity. They are good. They contain tocopherol, vitamin E, carotenoids, and pro-oxidant, small quantity of water. They favor rancidity, which is not desirable. Transition metals, small quantity of iron, copper, polar lipids, right? Lipids which have polar end, chlorophyll, right? So these are all pro-oxidant. In general, it is difficult to find a process that will remove the pro-oxidant without removing the antioxidant. So it is clear that from the oil, the pro-oxidant must be removed and the antioxidant must be retained. But किस्मत यह है कि when we remove the pro-oxidant, some antioxidant also get removed. It cannot be helped. And if you look at the label of many commercially available oil, they will show that after processing, an antioxidant has been added to the processed oil to replace the compounds that were removed during processing. The reason being, when we aim to remove the pro-oxidant, some antioxidant by mistake or by default get removed. They have to be made up. So after processing, we add those antioxidants, which will be shown in the label antioxidant added antioxidant. Okay. Now, vegetable oil extraction. The very simple flow sheet. You see the oil sheet, right? They must be clean because there may be some mud and dust on their seeds. Must be clean and dehulling, you have say groundnut. So the groundnut shells must be broken, or it may have a slightly layer of covering the seed that must be removed, and then this goes through what is known as cracking rolls, where it is just crack, and then it enters into the expeller. This is the main equipment for oil extraction, where the seeds are just squeezed, right, crushed, and the oil is squeezed out, and the remaining forms a cake, and the cakes, some more oil may be recovered from it, or you just dispose it to as animal feed, right? So the cake, some more extraction, some leftover oil in the cake. Cake is a solid one. Remember, from the expeller, there are two outputs. One is the solid output, which is the cake, which is goes typically as animal feed, cattle feed. Or some amount of squeezing can be done to this cake, and some more oil can be extracted. But the other output from the expeller is the oil, which comes now to the extractor, right? Where in the extractor, we use a solvent. Typically, the solvent used is hexane, right? Hexane is the most preferred solvent for oil extraction of edible oil. And then you get the solvent carrying the chemicals, and then the solvent must be recovered and recycled. And you have now so here again you see the, you get a solid product where the solvent is removed and the meal, that is this cake, is taken to dryer, right? And the oil now comes out, it goes for vacuum distillation, right? See, the vacuum distillation is to ensure that the temperature conditions are not very severe and the oil doesn't get deteriorated, right? So we do a flash film evaporation, that is reduce the pressure, because the pressure here and here will be different, and by reducing the pressure, the solvent is ejected out, which is recycled back, and then the oil goes into a vacuum distillation column, right? And where else? So here the oil comes. So this is the cake, and what else there? This goes to a mixing tank where alkali is added, right, for neutralizing, and then centrifuge, and then the clear oil comes, then a mixing tank where we add filler and filler aid, fullers here. See, the purpose of this is there may be some chemicals which add a very dark color to the oil, and fullers here is a clay, special clay, like that multani mitti, and it removes the coloring chemicals, right? That is, some chemicals in the oil which bring undesirable color, they are all stuck to the fullers here, and the clean oil goes now for finished, that's it, packing. Okay, so here also you have the extracted oil. So you see the simple flow sheet. Now let's see some of the explanation for them. cleaner and dehulling. Why cleaning and dehulling is done? Mechanical cleaning is done to remove stone and other undesirable material. Dehulling removes the hull, dry outer covering of the seed. Then cracking rolls. This is a cracking roll, and crushing rolls is similar to your cane juice type, but two rolls are there and the seeds pass through. As they pass through, they get crushed. Crushing rolls crush the oil seeds and get flax seed. Flax seed. This is broken, small pieces. And then go to the digester. This is the same expeller digester. 100 parts of flax seeds are thoroughly mixed with 5 to 10 parts of water by rotating blade. Softening by means of heat and moisture is done, and steam is added for heating purpose. Acid is formed by hydrolysis of ester. The seeds get swollen up. Then comes your expeller. Yes, this is the expeller. This is your digester. Then comes the expeller. The swollen seed. Why it is swollen? Because it has been treated with steam, so the seeds absorb the steam and feel swollen up. The swollen seeds are crushed under great pressure, right? And cells of seeds get ruptured. The cells in the oil seed, they carry, like in small pouches, the oil, they get ruptured and the oil is released. The tapering shape ensures, see the tapering shape, look at this, it is tapered, right? So the tapering shape ensures more application of pressure on the seed. The oil depleted cake is either sent for solvent extraction or used as animal feed. That's what we said. From this, it may be used for extraction or for animal feed. Then there is a mix tank. This is a mix tank. The extracted oil is treated with alkali like caustic soda or sodium carbonate to remove fatty acids. It also removes heavy metals which can start oxidation of oil. So the mix tank is where alkali is added. Alkali could be, as you see, could be caustic soda or sodium carbonate, and then goes to centrifuge. Acids are separated in centrifugal separator. The separated acids are used as food for soap manufacturing. Then comes the rotary filter. The clear oil is treated with some bleaching agent like Fuller's earth or activated carbon in filter aid before rotary filter. The rotary drum filter is used for removal of seed particles which may be present. The finished oil is produced thus, and from this process around 1 to 2% oil content remains in the meal. That it is in this meal, right? Extractor. The flake seeds or oil extracted seeds from crushing roll are fed to a moving bed, and the oil depleted cake is also added in the extractor. This part of it. The solvent extracts oil from the seed, and so this is the solvent extraction. And the solvent typically used is hexane. The wet meal, the left seed part is collected in the middle and is sent to the solvent removal. Solvent removal, steam is used to extract the solvent carried by the oil seeds. And the rotating blades ensure better exposure to steam. The solvent-free meal is sent to the dryer and then used as animal feed. Solvent is collected from top and it is recycled. Then you have a flash film evaporator. Flash film evaporator. The solvent is preheated by steam. Oil is concentrated here by evaporating the more volatile component, hexane, which is the solvent, and the hexane is recycled back to the extractor after heat recovery. The use of flash evaporator reduces the cost of vacuum stripping column. Right. Then vacuum stripping column, the oil from flash evaporator is fed here. Vacuum column. The stripping is done by steam. That is, steam carries away the hexane. So steam carries away the hexane and it is recycled back. Under vacuum, the boiling point of hexane and oil are close to each other. Jet ejector is used here to generate vacuum and the hexane is recycled again. Oil produced here is either directly used or sent for purification. We also hear a term RBD oil. Edible oil which are purchased in stores are known as RBD oils. RBD stands for refined, bleach and deodorize. Refined, bleach, deodorize, RBD, RBD. Then each of these steps is used to create a final oil that is consistent in taste, color and stability. These are finishing operations. As a result, these oils are generally tasteless, odorless, colorless, regardless of the original oil seed type or quality. Right? You see, the oil you buy from different manufacturers will be different because the finishing is different. Right? While this is the intent of the processing, a locally produced oil may not need to meet the same expectation as the mass marketed oil. You see, the mustard oil by some company will have a darker color, some other company will have a more lighter color, right? Then refining. So we are just looking at what is RBD. R stands for refining. Refining is neutralizing the fatty acid, removal of phospholipids, which is a compound containing phosphorus, filtering the oil. Other processes may also be carried out to create a more stable oil for subsequent processing. On a small scale, removing hydratable and non-hydratable phospholipids is one goal, because this is the phospholipid removal, and while removing particulates through filtration, the second objective. Hydratable compounds are one that will dissolve in water. Non-hydratable will not dissolve in water and will often settle out or be removed by filtration. There's a small amount of water in edible oil, so water is present to dissolve the hydratable compound. A simple acid wash of the raw pressed oil will cause many of the hydratable compounds to settle out of the water and become particles that can be settled, centrifuged or filtered from the remaining oil. These are removing the hydratable and non-hydratable. Then citric acid is often chosen as acid for this refining purpose. In one process, the oil is heated to 80 degrees, that is 176 degrees F. The oil is mixed in a solution of 2% citric acid and 98% oil. The acid is composed of a solution of 30% acid with 70% water. So the total mixture is kept at 80 degrees C for about 15 minutes, then rapidly cooled, settled and separated by a centrifuge. Commercial operations may include additional process in the refining stage. Bleaching. Bleaching is, I told you that there may be some chemicals which add color to the look of the oil. So by bleaching, it can be removed. And oils have a characteristic color when initially pressed. Pressed means the seed is squeezed. And when present on a grocery store shelf, vegetable oil from different seeds have the same nearly colorless appearance. These oils have been bleached to remove the minor constituents that cause the color. Other components, some of them desirable, are also removed during bleaching. Right? Bleaching removes the oil component that increases the rate of oxidation. When oil is used at high temperature, for example, when pan frying or deep fat frying, oxidation is accelerated. The oil may develop undesirable characteristics such as off flavor or dark color quickly. Bleaching allows the oil to be used for a longer period of time before the undesirable characteristics occur. Okay. Then to accomplish bleaching, the oil is mixed with required amount of bleaching clay. This mixture is heated to a high temperature of 90 degrees C, 194 degree F to 110, 230 degree F. in the absence of oxygen and mixed. The undesirable and desirable compounds in the oil attach themselves to the bleaching clay particles. So filtering or centrifuging will remove you the clay particles and the compound attached to the clay, resulting in an oil that has the colorant component removed. Then deodorizing. Some chemicals bring a funny odor to the oil. Right. Remember, many people when they buy mustard oil, they open and smell to see how pungent it is. Right. When pressed oils contain a variety of components, these include vitamins, fatty acids, protein fragments, traces of pesticides, and occasionally heavy metals like many other materials. The majority of these either enhance or detract from the flavor and smell of the oil. So the process of deodorizing removes all these components from the oil, leaving it flavorless and odorless, essentially the same as other oil which are deodorized. Okay, so the process involves steaming the oil and vaporize the unwanted components and separate them from the desired material. For the small scale or local producer, this process may not be desired for several reasons. Deodorizing removes the flavor and odors which are often prized in oils, enhancing the flavor of the food they are used to prepare. And this process requires additional equipment which can be costly to purchase and maintain. So to quickly sum up, you have the oil seed planting, the plant is harvested, then the seeds are collected, cleaning, shelling, crushing, and conditioning, and then go to the expeller. Expeller is, I told you where the rotating drum will squeeze the oil out and chuck the cake out. Right? You get a press cake, it goes for flacking, and then hexane extraction. So you can recover the hexane, and here you get the pressed raw oil, which gets filtered. So then it goes for bleaching, because the bleaching here is meaning is the same like pulp bleaching, but the chemicals used are different, right? Here bleaching is normally done with some very special clay like fuller's earth, etc., or activated carbon, right? Then deodorizing, and then the processed oil, and the remaining is recycled back. Okay, just to have a quick glance of, we'll come to it at the end. Okay. Then hydrogenation of oil. Now you see, I told you oil is liquid, whereas ghee is solid, butter is solid. Why it is so? Hydrogenation process is used to remove, see, the oil contains hydrocarbon. Some of them are saturated, some of them are unsaturated. Unsaturated means they have double bond, right? So the double bond carbon, they have to be removed, means you have to hydrogenate them. And to make fats and oils saturated, hydrogenation also raises the melting point and improves the resistance to rancid oxidation. So hydrogenation of the oil is a very desirable step to happen. The most common end product of hydrogenation is vanaspati ghee, right? Other products include vegetable ghee, hardened industrial oil, and partially hydrogenated liquid oil. Now, how does the hydrogenation take place? So, assume that my oil is like this, R1, R2 with carbon, carbon C double bond C, X time, plus X minus Y hydrogen will give me R1, then the hydrogen saturates them, then R2. You see this example, C17, H31, COO 3 times CH3, H5 plus hydrogen, 3 hydrogen. Three hydrogen, right? So you form C17, carbon remain, H31, 2 hydrogen gets added, becomes H33, COO remains intact, 3 times, C3H5 remains intact. Then for doing this, we use a nickel catalyst. Not any nickel, only nickel which is in activated state. That is known as Ni star. Ni star means nickel in a activated state. That's why it is known as activated nickel. Right? Nickel catalyst preparation. This is the nickel HCOO2H2O. It forms nickel, carbon dioxide, hydrogen, water, and temperature is typically 190 degrees. This produces a finely divided catalyst which is preferred for well-stirred hydrogenation reaction. So this is the main reaction. To do this, we may use nickel by this method or by this method C, nickel hydroxide plus hydrogen forms nickel and water. Similarly, nickel carbonate with hydrogen forms activated nickel with hydrogen and water, carbon dioxide. Nickel salts are precipitated and on inert porous carriers such as Kieselguhr or diatomic here and reduced at high temperature. Nickel catalyst preparation. So see, to do this reaction, we will do this or this or this, B, C or D. Okay, so nickel catalyst we may be done by aluminium nickel with caustic soda forms nickel alloy plus NaAlO3 and 3 hydrogen produces spongy high surface or catalyst when the sodium aluminate is washed with water. So here you have the hydrogenation process. So we have the catalyst. Remember what is the catalyst that is used? Activated nickel. Activated nickel catalyst. So here the catalyst is separated and recycled. Then this is a vacuum deodorizer. The reason for doing in vacuum is when the conditions are severe. Severe means say 50, 60 degrees, 80 degrees. Then it's not allowable to put this into that. Right? That way we do vacuum distillation. So this Dow term is a chemical which is used for supplying heat. Then decolorization, which is done by Fuller's earth, etc. Then filtered and the waste solids are removed and the extracted oil comes out. Functional role, hydrogenator. Hydrogenator, you are feeding the oil with a catalyst. Oil is fed to the hydrogenator. Hydrogen and steam is introduced in it. The catalyst oil slurry of concentration 5 to 15 kg per ton of oil is also put. The reaction is slightly exothermic, so steam is sometimes turned off. Because it's already exothermic, so some amount of heat is produced, so you need not supply steam. Deodorizer. The hydrogenated oil is now fed to vacuum steam deodorizer. It operates on a continuous basis. Okay, then comes finishing. Finishing is oil color is removed. That is, sometimes the oil looks dark colored and very thick dark, let's say even. Right? Oil color is removed by treating with Fuller's earth or carbon, activated carbon. It is then filtered, mixed with some vitamin. Now the finished oil is sent to hydrogenation for packing and storage. Some terms associated with edible oils. So rancidity, we have been hearing about it. See, the moisture and oxygen cause deterioration of fats. The combined action of both moisture and oxygen causes rancidity, which is characterized by a bad smell, development of red color, the oil looks reddish, increase in acidity, increase in viscosity. During frying, cooking, baking, oils undergo hydraulic and polymerization reaction. Okay, and these reactions are undesirable in edible oils. Prolonged exposure to air yields undesirable resin-like product, causing rancidity. Then winterizing. See, when oils are cooled slowly to a low temperature, then less soluble glycerides, rich in fatty acid, crystallize out. These crystals can be secreted by centrifuge or by filter, and that is known as winterizing. Then saponification. It is the alkaline hydrolysis of fats and oils is known as saponification. Hydrolysis of the fat. This forms the basis of soap making. And saponification values indicate the average molecular weight of a fat or oil. So remember, fat or oil depends upon the fat content in the oil. That is indicated by the saponification value. The may also defined be as the number of messages of caustic and caustic potash required to neutralize fatty acid obtained by complete hydrolysis of 1 gram oil of fat. That is the saponification value. Then comes iodine acid value. It indicates the proportion of free fatty acid present in oil or fat. An acid value is the number of milligrams of caustic potash required to neutralize the acid in 1 gram of sample. Generally, acid value for most samples lies within 0.5. Then comes iodine value. Iodine value is a measure of extent of unsaturated fatty acid. It is defined as number of grams of iodine, and that combines with 100 grams of oil and fat. The iodine value of non-drying oil is less than 90%, less than 90 of semi-drying. The semi-drying oil has iodine value 90 to 40, whereas the non-drying oil is 90%. Now let's have a look at this, or we will see these videos when we finish. Then comes essential oils. Okay, what are essential oils? These are the perfumes, etc. Essential oils are concentrated plant extract that retain the natural smell and flavor or essence of their source. That is how this word essential oils came. It is oil which holds the essence of the oil. The oils capture the plant is scent and flavor or essence. So let's see. The unique aromatic compound give each essential oil its characteristic essence. Essential oils are obtained through distillation via steam and or water or aromatic conditions. Yes. So unique aromatic compound give essential oil the very characteristic essence. So essential oils are obtained through distillation, maybe steam distillation or water or mechanical methods such as cold processing. Once the aromatic chemicals have been extracted, they are combined with the carrier oil to create a product that is ready for use. The way the oils are made is important as essential oils are obtained through chemical processes and are not considered true essential oils. Popular essential oils include peppermint, lavender, sandalwood, rose, jasmine, lemon. The essential oils are the most commonly used in practice of aromatherapy, in which they are inhaled through various methods. Essential oils are not meant to be swallowed. The chemicals in essential oils can interact with the body in several ways. When applied to your skin, some plant chemicals are absorbed. It's thought that certain application methods can improve the absorption, such as applying within the neck or uh, with heat or different areas of the body. Then research in this area is not much. Inhaling the aromas from essential oils can stimulate areas of your limbic system, which is also part of your brain that plays a role in emotion, behavior, sense of smell, and long-term memory. Interestingly, the limbic system is heavily involved in forming memory. Ya data hai. This can partly explain why familiar smells can trigger memories or emotions. What is steam distillation? Nothing much. Distilling in the presence of steam. Steam distillation is a process used for recovery of volatile compounds with high boiling point from inert and complex matrices, solid or liquid, using saturated or superheated steam as separation and energy agent. The process used for the extraction of essential oil from plants. Hydrodistillation is a similar process where is the hydrodistillation is a process where the plant is boiled. See, the other case, you put the plant material and steam is passed. Now here we are, lot of uh, plant where you are boiling, you are adding the plant material with the resultant steam being captured and condensed. See, our raw material has some oil and steam will combine with that oil and come out, and then we will separate the steam and oil. Okay. So when steam distillation is used in the manufacture and extraction of essential oil, the botanical material is placed in a still and steam is forced over the material. The hot steam helps to release the aromatic molecules from the plant material, since steam forces open the pockets of which oils are kept in the plant material. So the molecules of these volatile oils, they escape from the plant material and evaporate into the steam. Okay. So the temperature of steam needs to be carefully controlled, just enough to force the plant to let go the essential oil. If it is too hot, you may burn the plant, or it may just get cooked, which you don't want. Okay. The steam which then contains the essential oil is passed through a cooling system. So steam walks away with the essential oil, and then we'll have a cooling system to condense the steam, which forms the liquid from which the essential oil and water is then separated. The steam is produced at great pressure than the atmospheric and therefore boils above 100 degrees, which facilitates the removal of essential oil from the plant material at a faster rate, and in doing so prevents damage to the oil. Steam. This is a simplified process of the flow sheet. You can see the plant material is here in this. This is the main equipment. Then there is a removable lid, and this is a boiler from where the steam is generated, and the steam is sent to the plant material, steam. And from the top, the steam is taken out, then comes to a condensate. There's a cooling water applied here, and there we get our product. Okay, which may go for any more polishing and finishing. And this side, we may take the remaining material to the steam boiler and heat it. So mainly this is the steam making process. Now lately, carbon dioxide and supercritical carbon dioxide extraction are best done. Traditionally, it has been steam distillation, but now there is a switch over to carbon dioxide and supercritical carbon dioxide, are both latest technologies in distilling essential oils at low temperatures. Both methods involve use of carbon dioxide as a solvent, which carries the essential oil away from the raw plant material. The lower pressure CO2 extraction involves chilling the carbon dioxide to 35 to 55 degrees F and pumping it through the plant at 1000 psi, that's 69 bar atmospheric pressure. The carbon dioxide in this condition is condensed to a liquid, right? Then comes supercritical carbon dioxide extraction, which is the SCO2, supercritical carbon dioxide extraction. This involves carbon dioxide heated to 87 degrees F and pumped through the plant material at 551 bar, high pressure. Under these conditions, the carbon dioxide is likened to a dense fog or vapor. With the release of the pressure, the carbon dioxide escapes in the natural gaseous form, leaving the pure essential oil behind. Last, you have something called cold pressing of citrus oil, right? You know, you have an orange, the orange, when you peel the skin, you just press the skin, you will see some oil splurting out, right? Lemon oil and the like, bergamot, orange oil, lemon oil. This method involves the simple pressing of the rind. Rind is that outer cover, say, of the orange, right? That is rind. That is done to 120 degree F to extract the oil. Little, if any, alteration from the oil's original state occurs, the citrus oils retain their bright, fresh, uplifting aroma. For more details, there is a Fragrance and Flavor Development Center, FFDC, under Ministry of MSME, Government of India, GT Road, Makarand Nagar, Kannauj. I think Kannauj is about 2 hours from Kanpur or Lucknow, etc. This is the website of this FFDC. I think they also offer internship. I would like some of you who are interested in this essential oils to approach FFDC, and then we will see what to do next. So there are several YouTube which are relevant. I'll just come to them. We'll come to them one by one. First comes how the oil is made. There you are. Are you able to see the video?
Yes, sir.
Hello?
Yes, sir. We can see the video.
Yes.
Is a
it's on.
fat extracted from the fruit or seeds of certain plants, such as corn, canola, cottonseed, sunflower, or soybean.
Sunflower
There are
oil.
various ways to extract the oil. The method we're about to see is called cold pressing. The whole process starts with seeds, in this case a dark variety of sunflower seed. Cold pressing yields less oil than other methods, so it's usually just smaller specialty companies that use the process. The big vegetable oil makers tend to use solvents and high-pressure, high-speed presses. That's much more productive, but it also generates heat, which darkens the oil and diminishes its flavor and nutritional value. These seeds, shells and all, will go through this low-pressure press. The temperature inside is kept below 40 degrees Celsius, hence the term cold pressed. The press operator has to carefully monitor and adjust the speed, pressure, and temperature. Keeping the press cool is no easy task, given the heat that mashing seeds naturally generates. The pressing mechanism, the screw press, is made up of several sections, so they can shorten or lengthen it according to the type of seeds they're pressing.
The oil is cake. The oil is dripping here. The expeller.
100 kilos of seeds per hour go through the press, producing some 38 liters of oil. Low volume, but high quality. The seed residue, called seed cakes, is later sold for animal feed. Now though, it's key to monitoring temperature. If the seed cakes are too warm, that means heat is building up, and the exit opened wider to reduce the inside pressure. Once the oil is extracted, it's pumped through a filtration system. These cloth filters allow the oil to pass through, with remaining seed residue being caught. The oil runs through the filters repeatedly until it becomes clear. Mastering the art of cold pressing takes a lot of experience, but it results in oil that's healthier and tastier. Cold-pressed oils made from other seeds pose different production challenges. Flax and hemp seeds are extremely sensitive to heat, so workers have to cool the press during the process to offset the heat that pressing generates. Canola, on the other hand, isn't particularly sensitive to heat. Nor is sesame. All natural, no preservative oils like these have to be carefully handled because exposure to air spoils them prematurely. Plastic isn't airtight, so the oils are filled into dark glass bottles. Dark because the oils are also sensitive to light. The bottles are sealed with flow control caps. Without preservatives, sunflower, canola and sesame oils have an 18-month shelf life. But flax and hemp seed oils have to be refrigerated, and even then, they go off after just a few months. But it's all worth it, because they taste so much better than their mass-produced cousins.
Then how the hydrogenation is done?
So I'll be looking at the hydrogenation of oils. We'll start by looking at the difference between fats and oils. Fats are solids at room temperature, whereas oils are liquids at room temperature. Fats are composed of molecules with carbon-to-carbon single bonds. Oils, on the other hand, are composed of molecules with carbon-to-carbon double bonds. On the left, we can see the structure of a saturated fatty acid that has carbon-to-carbon single bonds. On the right, we can see the structure of an unsaturated fatty acid that has carbon-to-carbon double bonds. The presence of carbon-to-carbon double bonds has an effect on the melting point of the fatty acid, which we'll look at next. The melting point of fats and oils depends on two factors. The first factor is the molar mass of the molecules. Greater molar mass results in stronger London dispersion forces between the molecules and a higher melting point. The second factor is the surface area between the molecules. Saturated fatty acid molecules have greater surface area between the chains, which results in stronger London dispersion forces and a higher melting point. Next, we look at different fatty acids and their melting points. So in this table, we have the name of the fatty acid, its formula, whether it is saturated or unsaturated, and its melting point.
Some are saturated.
The first four examples are saturated fatty acids with carbon-to-carbon single bonds. The melting point of the first four fatty acids increases as their molar masses increase. The last two fatty acids are unsaturated fatty acids with carbon-to-carbon double bonds. Oleic acid is a mono-unsaturated fatty acid which has one carbon-to-carbon double bond. Linoleic acid is a polyunsaturated fatty acid which has 2 carbon-to-carbon double bonds. If we look at the melting points, we can see that as the number of carbon-to-carbon double bonds increases, the melting point carbon-to-carbon double bonds there are in a fatty acid, the less surface area there is between the molecules, London dispersion forces, and the lower the melting point. Next, we look at hydrogenation. Hydrogenation converts liquid oils into solid or semi-solid fats.
Nickel cat, please.
In hydrogenation, hydrogen is added to a carbon-to-carbon double bond. The reaction
Double
takes
bond,
place at
single
high
bond.
pressure in the presence of a nickel catalyst. The product of the reaction is a saturated fatty acid with carbon-to-carbon single bond. R. It increases the melting point and it decreases the rate of oxidation, which
Longer
means
shelf
a
life.
longer shelf life. Partial hydrogenation can lead to the formation of trans fats that increase levels of LDL cholesterol. So
See, there's
here we can
something
see
called
the
partial
hydrogenation of a
hydrogenation,
cis
which I think
isomer.
is
On the
not
left, we have
permitted
complete
now.
hydrogenation, which produces
You may do
molecules with
complete or
carbon-to-carbon
partial.
single
Partial is not
bonds.
allowed as per law.
On the right, we have partial hydrogenation, which produces the trans isomers, are known as trans fats. And finally, oils. So trans fat, saturated fatty acids, increase the levels of LDL cholesterol in the body. LDL, which is low-density lipoprotein, transports cholesterol to the arteries, where it leads to thickening. Sources of LDL cholesterol are saturated fats, such as lauric.
Then we have a video on how to do the essential oil. This
We
is
have a bit of a
interesting.
different video for you this week. We're going to take a break from our brewing equipment
This is
and show
lavender
you
oil.
how some of our
You
stills
know,
work.
lavender oil is
In this
used for
episode, we're
fighting
actually going to show you how
acne,
to steam,
dry
distill lavender
skin
oil
lightening,
and hydrosol
wrinkle removal,
using our essential oil still.
anti-inflammation.
The video is actually
and
shot by our
wound
friends out at the
repellent.
Rabbit Mountain Lavender Farm
The
in Boulder, Colorado.
lavender
So
flower.
many thanks to them. Essential oils are valued for their medicinal qualities. They're used for aromatherapy. Some people cook with them, and other folks sometimes add a dash to cocktails. If you've ever purchased essential
See, a
oils,
place like
you know how
Kannauj,
expensive they are.
almost every
Having
house has
distillation
got a
equipment
distillery
allows you to make
making
any kind of
perfume.
oil you want at a
Kannauj is
fraction
known
of
as
the
the
retail
perfume
price.
capital
So
of India.
we hope you enjoy this tutorial, and please
France,
check
there is a
the
town
link in
called
the
Grace,
description for
which is the most
equipment
famous for
details if
perfumes
you're
and scents.
interested in doing
In
this
India,
yourself.
it is the equivalent.
So this is
Kannauj.
our lavender still setup. As you could see earlier, I
Nectar
put water
capital of
inside
India.
this vessel. This is our boiler. It's got an electric heating element in it that's attached to this controller, which allows me to control the temperature of the water inside
Steam
and slow down the
distillation.
boil if we're driving too much steam into the system. Steam exits our insulated pipe out of the top here, travels back down into the bottom of this vessel, which actually is packed full of lavender by our little helpers there. And as the steam passes through all that lavender, it picks up the various oils and other hydrosols, and it carries them up and through this column. We have this packed with some copper, in this case, not to increase the proof of a still, but instead to react with some of the sulfur that might have come out of the plant material in here, resulting in better smelling oil and hydrosol. So as our steam passes through this column up and out, comes this way, now we have cold water coming from, in this pipe, coming from the tap, and it's circulating up and through this little jacket, and then back out this way, and that's coming back around and watering our lavender plants. So we run cold water through there, that's our condensing column, and then our condensate, which should be lavender oil and hydrosol, will drip out here into our separatory funnel. A few gauges and places to keep track of things on here, pressure relief valves in case for some reason we build up any sort of pressure, and keep an eye on the temperature gauge here and know when we have steam actively entering the chamber. I also added a sight gauge on the back of this boiler so I know I don't run it dry and destroy our heating element. That's all there is to it. It's a pretty simple system, and works like a charm. Getting our first signs of steam in the column. So I just turned on the water, and now we're circulating. I hear this guy boiling. Now we've got some serious condensate forming. Things are really starting to boil in earnest. Still not seeing anything come out of the condensate tube yet. We're getting close. And you can definitely smell the lavender now. Okay, we've been distilling for about an hour, and I just shut the system down, turned off our controller, and pulled the hose out of our separatory funnel. And there on top you can see is a skim of lavender oil, and below that is all of our hydrosol. I'll let this sit for about at least 12 hours or so, and some of that cloudiness will come out, and that's still more oil. And then we'll use this stopcock to drain off the liquid until we have just oil in the vessel, and then we'll capture the oil. So that's it. Lavender to lavender oil in an hour.
So, see this essential oil extraction known as aromatherapy. It's a very interesting thing coming up. There are a lot of money being made in aromatherapy, and just have a look at this. Coursera offers a free course on aromatherapy. Aromatherapy, clinical uses of essential oils. Enroll for free. Some of you are interested can look up, right? So this is how you widen your spectrum of career progress. So those interested in essential oil aromatherapy, have a look at this Coursera course also. So I have uploaded these links there in the Google class. That is it, and thank you all, and have a great weekend for you.